Bismillahirrahmanirrahim. Today we are interested to know about heteroscedasticity. What is the nature of this issue? What are the causes, and what are the consequences of heteroscedasticity? So, first of all, try to understand that what this issue is basically. If you take into your account an example in which you are interested to know that how elite class and the poor people make expenditure on their food. So there may be some problem in the sense that the elite class don't bother about spending when they are interested in consuming food, whereas the poor class is very much concerned about the expenditure upon food. So, as the income increases, the elite class, you can say, does not spend as compared to the increase in income on the food. And on the other side, if you see poor class, so their spending on food may increase. So, if you take into your account only one series, let us say X is a series representing the uh, expenditure on food, and you are not taking into your account the elite class and the poor class at the same time. You are just taking the data, and there is no discrimination regarding poor class and the elite class. Then there may arise the problem of heteroscedasticity. But if you take into your account separate data for elite class, separate XI series, or in another case, if you are going to take data from the poor class and you are taking data from that class, then this issue may not be there. Okay, so let us say we have an equation yi is equal to beta 1 plus beta 2 xi plus ei. So you know that this is the sample regression equation. So heads will be there on the estimators. Okay. So from this equation, you know that part of spending on food is being captured by these two. So basically, you can say that this term is basically capturing the expenditure on food, and if there are so many other variables that may affect the spending, let me write spending or expenditure, and this is the income, let us say beta 1 hat plus beta 2 hat, and this is basically the income plus ei. So as you know, as income increases, the spending increases. So this is the expenditure on food, or you can write it down as instead of spending, you can write it down as expenditure on food. Okay, so as income increases, the expenditure on food also increases. But if you are not going to discriminate between the elite class and the poor class, then you are definitely taking the increase in income or income series. So you are not discriminating the poor and elite class. Then there may arise the issue of heteroscedasticity. So, first of all, if there is some issue of heteroscedasticity, how can you detect it? What will happen? Let us say in this relationship, there is there is an issue of heteroscedasticity. So, how will you detect it? Let us say you have some data for y. You are going to draw a graph. Okay. So when you will draw a graph, you may obtain the figure like this, where there is same variation around the fitted curve or regression line. So if same variation, okay, it means there is no issue of heteroscedasticity, or you can say the homoscedasticity is there. Okay. But if in another case the data gives you the graph like this, let us say this is the regression line, this was the income, this was the expenditure on food. Okay. So initially, when income was less, the variation was less. But as the income increases, the spread increases. The spread increases. So these are basically the dots. So now if you want to cover these lines, so these are basically, sorry, these are the dotted lines. So you can consider that this is the spread. The spread is like this, that it goes on increase when income increases. Okay. So in this case, you can say that as the variance or spread is being increased, is so therefore the issue of heteroscedasticity is there. So basically, we had studied homoscedasticity, in which we had the assumption that the constant variance over time. So if variance is not constant in the relationship, then it means that there is an issue of heteroscedasticity. Okay, and similarly, there may be another graph in which you may have the relationship in this way. Initially, the spread was higher, but with time, as income increases, the spread decreases. So in this case, the variance is being decreased over time. So this is basically the situation. So in this case, you can also say that there is an issue of heteroscedasticity or heteroscedasticity. So basically, by hetero, we mean unequal, and scedasticity or scedasticity means spread. So there, if you see this figure, there is a spread which is decreasing over time. So issue of heteroscedasticity is there. Okay. So now, what are the causes of this heteroscedasticity if this is there in the data? So basically, if you see, there may be several causes. Poor data sampling. Let me Causes or the causes. Bullet. Why it arises in the data? Let us say you were there in the field to collect some primary level data. So if you are not going to take into your account the proper sampling technique, so definitely you will have the data that would not be that much reliable. So if you are not taking into your account the proper sampling technique, then this problem may arise in data. So this is the one cause. Otherwise, the second cause may be wrong data transformation. So you have to transform data in proper way. Okay, if you are supposed to have log with it, you have to take log, or otherwise you will have the problem of heteroscedasticity. Similarly, there may be another reason: wrong model specification. So if your model is not correctly specified, then this problem may also arise. Then there is a third cause, and that is the presence of outliers in the data. So if there are outliers in the data, then this problem will be there, or most probably will be there. So you are familiar with the outliers. If there are some so big values or huge values, and if there are some so small values in the data as compared to the other values, so those big and small values distort the data. So therefore, uh, if there are outliers in the data, the problem of heteroscedasticity may be there. Similarly, skewness. Skewness of one or more regressors. Regressors means the independent variables. So if you are going to take into your account the independent variables and there is skewness in the data against them, then this problem may also arise. Okay. So then there comes consequences. So what are the consequences? Let me give the bullets to these. In consequences, what happens in the OLS estimated?
सर जी 5 नंबर जरा दोबारा एक्सप्लेन करें 5 नंबर
Skewness of one or more regressors. Okay, so regressors, if there are only one regressor, definitely, let us say there will be an X series. Okay, if you see this simple regression model that I have written over here, so only X is there. So definitely there will be some data against this series. Okay, so if you draw this data, these data on graph, okay, you will come to know that whether there is some skewness in the data or not. Okay, otherwise you can use the Pearson's coefficient of skewness or software coefficient to know that whether there is skewness in the data series or not. Okay, so this is relevant with the first course of statistics. Okay, so if we have data, we are able to find out the skewness. So if there is, basically we are interested in normal distribution. Okay, you are familiar with normal distribution and skewness. So if you are not familiar, then I think I can draw it. This may be considered as a normal distribution. Okay, there is no skewness in this, and you can say that 50% area are to each side of the mean, mode, and median. Okay, so mean, mode, median all are there in the center, and 50% area or 50% data are there to the left of this point, and 50% data are to the right of the side. So this is the normal distribution. But if this is not the case, and case is like this, okay, so it means that now the distribution is negatively skewed. So in this case, here will be your mean, here will be your median, and at this point, the peak value will be considered as mode. Okay, so if data give this figure, or otherwise, if data gives you data distribution is like this, so this will be considered as positively skewed. Okay, so in this case, mean will be to this side, here will be median, and at this point there will be mode. Okay, so if you draw the distribution and you obtain this normal distribution or near to this normal distribution, then you will say that okay, there is no problem. It is quite possible that there isn't any issue of heteroscedasticity. But if this is the case, so then there is a possibility of heteroscedasticity in the relationship. Okay, so now consequences. So is it clear?
जी सर जी क्लियर है
Yes, sir. Clear.
Okay. So now OLS estimators, what are the consequences of this heteroscedasticity? OLS estimators, OLS estimators, in the presence of heteroscedasticity, in the presence of heteroscedasticity remains, you can say, linear, straightforward, linear, remains linear. Better would be if I put comma here, remains linear or still linear, unbiased and consistent. However, OLS estimators are insufficient or become inefficient. Inefficient. That is, not having minimum variance. There is not having minimum variance. So as we know that the OLS estimators are blue, best, linear, unbiased, and efficient. So although in this case, if there is the issue of heteroscedasticity, they are unbiased, they are consistent, okay, but they have become they will become inefficient, and if they become inefficient, then it means that they are no more blue, okay, or they are no longer blue. So you can write down here. So estimators are no longer, so they do not remain blue. Okay, so they must remain blue if you are interested in making some decision on the basis of the regression model that you regress using the OLS method. Moreover, the heteroscedasticity affects the standard errors of estimators. by estimators I mean betas. Okay, so standard errors of the estimators are affected in case of heteroscedasticity. So if there is heteroscedasticity in the model, then OLS technique or method underestimates the standard errors of the estimators. This is what I have written over. So how it affects? It affects the standard errors of the estimators. How it affects? It underestimates. It underestimates. So whatever should be the value for the standard errors, in fact, we obtain lesser value. Okay. Or in other words, low standard errors we obtain. Okay. And what else? If heteroscedasticity is there in the model, we may have higher values of T and F. T and F statistics. You are familiar with T and F statistics. So higher values of T and F statistics may be resulted if heteroscedasticity is there. Okay. So higher values may guide you to the rejection of the null hypothesis. Okay. Then statistically significant coefficients may be resulted. So definitely, if you are going to reject the null hypothesis, then statistically significant coefficients will be there. And by this, you can also say that rejection of null hypothesis is often. Rejection of null hypothesis is in fact too often. Instead of writing often, too often. That mostly it occurs that you reject the null hypothesis. Okay, so you are familiar with this, what happens there when we are going to reject the null hypothesis, in which case we are interested to know the significance of the independent variables in some model. Okay, so it is quite possible that you are going to say that this is significantly affecting the dependent variable, whereas it should not be significantly affecting the dependent variable. So rejection is often there. Similarly, we also call this type 1 error, because you know that type 1 error is rejection of the null hypothesis when it should not be rejected. Okay. So T and F statistics are no more reliable, and as they are no more reliable in case of presence of heteroscedasticity, then you may reject the null hypothesis, whereas you are supposed to accept that basically that should be, or the null hypothesis should be accepted, but you basically reject it on the basis of T and F, the high values of T and F statistics. So therefore this heteroscedasticity may misguide you in this way. Okay, so these are the consequences. Now, how can you detect the heteroscedasticity in the model? Okay, so for that, you certain tests.
सर मैं सॉरी सर मेरा क्वेश्चन है
Yes,
ये हेट्रोजेनिटी और हेट्रोस्केडास्टिसिटी में कोई फर्क है?
yes, those are, there is a hell of difference. Okay, homogeneity and heterogeneity is something else, and Heteroscedasticity and homoscedasticity is something else. Basically, in case of heteroscedasticity, the independent variables or the regressors becomes, you can say, correlating with the error term. So between error term and the independent variables, if there is some relationship, then this problem rises. Okay. And if there is no relationship, then this problem is not there. Then we say that there is homoscedasticity in the model. Okay. So let us see how we detect this problem. So detection. And for detection, first of all, there is a test that we call Brewish Pagan LM test. Okay. What we do in this test, basically, better would be if I take into my account some other sheet. The last sheet better will be if I take basically I am using my marker here. It is going to select this. Detection Brewish pagan test will be the equation in this case. I'm not going to write on Brewish pagan again. Mu I square will equal delta naught delta 1 x1 I plus delta 2 I delta 2 x2 I plus so on plus delta k x ki plus vi. So this is some error term that we are going to denote with vi instead of ui, because we are using ui over here. Okay, so what we are doing, what this Brewish pagan test do, this test take the scale of the residuals and then regress it on the remaining regressors, and then see that what is there any relationship between these explanatory variables and the this term. So if there is some relationship, then we will say that there is an issue of heteroscedasticity. And if there is no relationship between the explanatory variables and the residuals, then we will say that if there is no relationship, it means there is no issue of heteroscedasticity. So let us see that how this British pagan test works. So let us say uh, these are the data. This is the Excel file, and these data are there. In this case, if you see income, this income is basically I'm taking as the dependent variable. So I am going to write with this X. So value is, let us say, X1. What is this value? This may be the case in which value of some house is there. Okay. So you can think in this case that if there are different homes with different values, so people with those are residing in the homes or houses where in the posh areas where the price of the value of the house is so high, you have data on those. And similarly, you may have data on those houses those are in the low cost areas. So it is quite possible that in this case heteroscedasticity may arise when you are going to regress this on the income of the residents. Okay, so these values are, you can say, the values of the houses. Okay, similarly, this is the other explanatory variable, and we may know it as x2. And by x2 we mean that the education level of the residents of the area which you are surveying. Okay, similarly, this age may be represented by x4, and by x4, by age, we mean the age of the residents. Similarly, this is mortgage. So by mortgage, you can that whether there is some mortgage regarding houses that you are going to survey, or some houses are pledged or not in this sense. Then there is gender, and you may take gender as x6. So now x6 means this is the gender, male and female. So if you interviewed a male person, so you will give the series value 1. And if you considered females or interviewed females, then you will give it value 0. Okay, so let us say these are our data, and now we are interested in finding out that whether there is an issue of heteroscedasticity or not. Okay, so as I'm saying that this is an issue that arises if the error terms are related with the explanatory variables. Okay, so first of all, you would have to find out the error terms. Okay, residual values. So how can you find out the residual values? You know that there is a technique that I used in the previous lecture. Using Excel, I found the uses matrices, and then I found the residual values. Okay, but in this case, I'm not going to take into my account that detail. Okay, so better would be if I use Eviews. Or otherwise, if you take into your account Excel and you only take into your account 1 or 2 values instead of all variables, only 1 or 2 or 3 explanatory variables, then let us see. First of all, if better would be if I show you that what will happen if you are interested in having the graph. Okay, so let us see. If you are going to insert a graph, scatter graph, this is the graph. Okay, and if you add trend line in this, so you will have this trend line. This trend line, is it visible to you? Is it visible? So in this case,
Yes,
if
sir.
you
Yes,
if
sir.
you see the residual values around this trend line means that sample regression line. Okay, this is the estimated line that you obtain using the values of alpha and beta and so on. So the spread is, you can say, is random. Okay, some values are above the line, some values are below the line, and this spread is being increased. If you see this way, basically Excel takes values in such a way that it considers, let me write down it again. From here, the relationship is also obvious, but basically, this Excel takes the X as a dependent variable and taking Y as an independent variable. So, if you are interested in having the proper graph, then you may write it down as this value series to this side. Okay, so now if you will draw the graph, then you will have some better graph, or the proper graph in which the dependent variable will be on the vertical axis. So now select this any point, select this, left click, right click, and then add trend line. This is the line. Okay, so now you can see that as the residual values or residuals are spread in such a way that apparently it looks that variance is constant over time. Okay, so there is no problem of heteroscedasticity. Basically, homoscedasticity is there in the model, which is required if you are going to use OLS technique. Okay. Similarly, you may check it for all other variables. Okay. And if you are interested in having the residual values over here only for these two, how can you find out that? Let me take this graph down so that I may have some calculations over here. Okay. So first of all, if I'm also interested in having display equation on chart. Okay, so let us have this equation. From this equation, you have the values of beta. Can you see this figure? I simply, because I know that you can find out the values of beta using the formula. So I'm simply asking Excel to provide me the values of beta. So this equation will be in this form. Y is equal to 0.0656x. So this is basically beta 1. And this is 89.722. This is your beta naught hat and beta 1 hat. So if you write down these values over here, what is beta 1, beta naught, or you can know it with A. So what is the value of A? A is your intercept, 89.722. So this is your intercept, and you can write it down B as the coefficient for the first variable, and basically you are taking into account the single simple regression function. So only one explanatory variable is there, and the slope variable is, the slope coefficient is 0.0656. Now using these two, you are able to find out the predicted value or the estimated value. Brother Samyuddin, you are asking about estimated values, and I explained that those values are basically the, you can say in this way, y, y hat. There is some problem. It is Calibri, the famous font. So use Calibri so that the y remains same. So y and capital y hat, y hat, y hat will equal alpha, in this case a and b. So a plus b x1, a plus b x1. So what is a? This is a plus b and x1. So this is x1, and you have to multiply this basically. This value plus this value, and then multiply this with this value. And if you recall, the previous lecture, I solved an example similar to this, where I gave dollar signs to these fixed values that we don't want to change. Okay, so this is the answer. And now when you will left click it twice, you will have there is something wrong. D4, not D4. It is not D4. It's basically A2. Enter. So these are the estimated values y hat. Okay, and now you know that residual value, which is denoted by E, and there is some issue. Okay, so E, small e, equals y minus y hat. What is this? Equal to, this is your y minus y hat. This is the answer. So these are the residual values. Okay, so I am just solving this example in which I took so many, basically multiple regression analysis I was interested in, but I will find the heteroscedasticity, the issue of heteroscedasticity using the Eviews, okay, in which I will take into my account all regressors. But in this case, I am just doing it manually. If you are interested to find out, or if there is a question in examination that whether there is the issue of heteroscedasticity or not, so how can you find out manually? So you will definitely take into your account the simple regression model, okay, because that is easy to handle. Okay, so therefore E is equal to y minus y hat. These are the values for the residuals. Okay, so I have shown you the graph. If you see this graph, and now I'm going to draw another graph in which I am interested to have the residual values against the dependent variable. So if I'm going to take into my account the residual values and the dependent value, so how graph will look like, let me do. I'm going to paste it again here. This was your dependent variable, and this is your residual series. Okay, so now we are going to have a graph for these two. So let us see what happens. This is the graph. Okay, some positive values are there, some negative values are there, and if I ask Excel to add a trend line, okay, so this will be the trend line. Okay, now basically I want to compare that graph with this graph. See these two graphs. See these two graphs. The spread is almost same. Okay, see these 3 points. Okay, see these points. So random variation is there. Okay, so they look like same. Okay, so we can also take help of the this chart, in which we take into account the residual values. We regress the residual. Basically, in this case, why is there on the dependent variable, as considering it as on vertical axis. Basically, I want to have this on the horizontal axis. So for that, what should I do? I would have to change the scale in the graph. Otherwise, I can also change the scale from here. Horizontal category. So basically, those residual values are there in the horizontal category. So if you switch it, let us see what happens. Okay, so this is the graph in that case. But if I take this series to this side, and now I see what is the graph. So this is the graph, and if I add trend line in this, this is the trend line. Okay, so now take this graph with you, come down, paste it here, and now compare these two graphs. Sorry. Let me reduce the scale. Okay. So random variation is there. If you see, random variation is there. Okay. So random variation is there in both graphs, in this graph and as well as in this graph. Okay. So there is no issue of heteroscedasticity in both cases. Okay. So you can also take into your account the residual values, and you can have a graph of these residual values against the actual y values. Okay. So when you are interested in having into your account simple regression model, then this will work in this way. And if it is the multiple regression equation or multiple regression model, then definitely there will be so many independent variables. More than one explanatory or independent variables will be there in the model. So in that case, definitely you will have one series for the residuals. In this case, as we have one series, in that case, you will also have one series. So it is easy to regress this one series against the actual values of y. Okay? Instead of regressing all variables separately on the uh, dependent variable, as I've done this was the case where I regressed x1 on y. So then if you are going to take x2 on y, then x3 on y, so if you are going to do all this exercise, and then you are going to know that whether there is an issue of heteroscedasticity or not. Or otherwise, if you simply take into your account the residual values and regress on the y values, then you will be able to know that whether there is the issue of heteroscedasticity or not. So let me regress it on the y hat. Let me regress it on the y hat. What happens if I regress this on the y hat? If you take graph for this, so there is so much variation. So this graph is more appropriate. If you see, this look likes this graph. See these two graphs. Let me, then this not remain visible. Copy. Okay, so this will be the case in the sense. So again, the variation is random. Okay. So you can also take into your account the residual values and the income, or otherwise you can separately regress different explanatory variables on the y, and then you can find out whether there is an issue of heteroscedasticity or not. So now I have taken this data here, okay, and I am going to use all these variables, explanatory variables, to find out the regression results. So how will I? Quick estimate equation. The dependent variable is income. So you will write down here income, and then you will double click here. C, the constant, and there comes value. So write down value, double click on value, give space. The third variable is education. So write down education, E space, and then write down gender. So gender is there. Then there is mortgage. Then there is mortgage. Okay. So then there is age. So write down age. So OLS technique. This is the regression. These are the regression results. So you can see from probability value that mortgage and age, these are insignificant. Mortgage and age These are insignificant. So you may drop it, these two one by one from the model. Okay. And if you are interested in finding out that whether there is an issue of heteroscedasticity, then you have to press view, residual diagnostics, and heteroscedasticity tests. So here are the tests that I am going to discuss. Jewish pagan that I wrote in the Word file first, the equation for that. So if you are interested in finding out the results for Bruce pagan Godfrey test, you will press this. It is automatically clicked. So if you will click here, okay, you will have the results. Okay, so in this case, you have to take into your account this observed R square, and against this, if you see, probability value is 0.96. So in this case, basically, we are taking into our account the null hypothesis that there is no heteroscedasticity. There is no heteroscedasticity in the model. Fine. So you know that if probability value is less than the level of significance, then we reject H naught. Okay. So if the level of significance in this case was 5%, so it is 96% greater than the level of significance. So in this case, you are going to accept the null hypothesis, and the null hypothesis is there is no heteroscedasticity in the model. So as we are going to accept the null hypothesis, it means that there is no heteroscedasticity in the model. So you should not be worried about this. Okay. So in the model, there is no heteroscedasticity in this case, in this particular case that we are solving. Okay, but if there was this value was less than 5%, 0.96 was 0.96 is there, but it was, if it was less than 5%, okay, then there was a problem of heteroscedasticity. Okay, so if you see in some case that this value is less than 5%, then you will go for the removal of heteroscedasticity. So now how can we remove the heteroscedasticity if it is there in the model? So if in some case heteroscedasticity is there in the model, then we can simply take the log of the values, log of the variables that are there in the model. So when you will take log of the variables, then this issue will be removed. Fine. So removal is possible if you take into your account the log. So this is all about heteroscedasticity. Any question?
No, sir. फिलहाल तो नहीं.
So if you take into your account this value, this ui square, delta naught, delta 1, x1, and so on. Okay. So in this case, what is basically this Bruce-Pagan test is doing, that you straightforwardly obtained using the Eviews. If you are interested in regressing this equation, how will you regress it? Okay. So for this, come over here in the Excel, and there is no need of this whole. According to the Bruce-Pagan test, you have to take the square of residuals. Okay, so how will you take the square? Square these values. Okay. Square these values. Now, when you will regress this on the explanatory variable, and you will check the relationship, that relationship will also tell you about the presence or absence of the heteroscedasticity. So basically, this is the relationship between the residual term and the explanatory variables. So let us have the regression results in this case. So for that, data analysis, regression. Okay. And in this case, if you see input range, so what is the input range? In this case, you will take these residuals and as dependent. So this is the range. Okay, and x, these are the x values. So have this in this way. Then labels are there, labels are there, and constant is not 0, it is some value over there. Then give it output range. So I'm going to give it the output range as I want to have the result over here. Let us say I want to have the result over here. Okay, so now if you are also interested in plots, so residual plots may also be there. So I am asking it to provide me the results. So what is your opinion? The probability value is so small, 5.25 raised to the power minus raised to the power 5, 5.25 raised to the power minus 5. So it means that 0.00005. So less than 5%. Okay, what this means? This means that the null hypothesis, in which you are saying that there is a relationship between the explanatory variable and the residual, there is a relationship. So you are going to reject. What you are going to do, alpha is 5% and the probability value is less than that. So in this case you are going to reject the null hypothesis. Okay, so rejection of null hypothesis, what that means? That means there is relationship. The alternate hypothesis will be accepted. What's wrong with this? I don't. What is this value? Is there anything wrong?
सर मेरे ख्याल से वैल्यू मिस होगी और के ऊपर ट्रांसक्रिप्ट लिखा गया है।
There is something wrong. Okay, okay. Y hat is missing basically. Y hat is missing. If you see, Y hat series is not there now. Okay. So if it was there, then everything was fine. So where is that? Plus this multiplied by this. So before pressing enter, give dollar signs. And also give dollar sign to this. So now press enter. This is the value y hat. Now B2. So this is not B2. This is basically yes, B2 minus C2, y minus y hat. This is equal to this value. So now if you press double click this, B2 minus K2. So this is not K2, this is C2. Enter. This is the value. Okay. So now if you are going to regress x1 on e2, e square basically. So what will be e square? E square is d2 square. So this series is correct. Okay. So now let me find the regression results. If you are interested in regressing x1 on e2. Okay, so data analysis, regression. Okay, this is your dependent variable, and in this case this is your independent variable. Labels are there. Output range I'm going to give over here, and now press OK. Let us see what happens. Okay, so now see, this is the correct answer. So now in this case, if you see, 0.02 is the probability value. In this case, 0.02 is the probability value, and the significance level was alpha 5%. Okay, so probability value is less than alpha. So what this means? Reject H naught. Reject H naught. So rejection of H naught. What was H naught? H naught was the case that there is some relationship between the explanatory variable x1 and the dependent variable. In this case, that was e square residual. So there is relationship. So there is some issue of heteroscedasticity. It means there is some issue of heteroscedasticity. If there is some relationship, yes, there is an issue of heteroscedasticity. If there isn't any relationship, that then if you're going to accept the null hypothesis, then that will mean that there is no relationship between x1 and the e square. Okay, so we are basically interested in no relationship. There shouldn't be any relationship. If there is some relationship, then there is the issue of heteroscedasticity. Okay, so this is all about heteroscedasticity. So you can check one by one, or you can straightforwardly use the Eviews to have the answer. So then there is another topic, stepwise, you can say, removal of the variables or inclusion of the variables in the analysis. So if you are as you are interested here in this case, if you see the probability value for mortgage and age. Okay, so these two, if you take these, in fact, three: gender. This is the, so no, this was the heteroscedasticity test. Leave it. If you simply have the equation income, regress it on value, then education, then age, then there is mortgage, and then there is what's left over there, gender. Okay, so this is the output. So you can see from here, against value, if you see the probability value, this is less than 5%. It means that value does affect the income. The value of house does affect the income of the residents. Then education. So education is also, you can say, significant. Okay, you will reject H naught, means there is relationship between education and the income. And similarly, if you see uh, age, in this case, if you see 0.13, it is greater than point, or you can say 5%. So therefore, what will you do? You will remain unable to reject H naught, or basically you are accepting H naught. Exception of H naught means that age is not affecting the income. Okay, similarly, if you see this case, mortgage, so mortgage is also this value, this probability value is more than 5%. So mortgage is also not significant in this case, or you can say insignificant in this case. So out of these two, first of all, you would have to remove mortgage, and then you will see that whether uh, in absence of mortgage, age impact upon or affect the dependent variable or not. So let us first remove mortgage from here, have the answer. This is the output. Again, if you see age is there, that is insignificant. So now you will remove age. So basically I am interested to convey this message to you that don't straightforwardly exclude all the insignificant variables at once. Okay, remove those variables one by one. Okay, so in now you will remove age, and then you will see. So now remove age because it is insignificant. Okay, so this is the answer. So now if you see all variables that are remaining, three: value, education, and gender. So value of the house, education of the residents, and gender of the residents. These three are significantly affecting the income of the people or residents in that locality which you surveyed. Okay. So now if you are also interested in finding out the issue of heteroscedasticity, you can check from here. And if you are interested to know the multicollinearity, so you can also check that. And as I have explained that you are interested in knowing the variance inflation factor. So if you see this value is much less than the 10, that is the fixed value that we consider, that whether there is the issue of multicollinearity or not. So if you see these values, these are much less than 10. So it means that there is no issue of multicollinearity in the model. Similarly, if you are interested in knowing that whether there is an issue of heteroscedasticities or residual diagnostics, heteroscedasticity tests, and now you can say, check for different tests. So if you are going to check for Bruce-Pagan, press OK. Okay, and you see 0.6609. You have to concentrate upon this figure 0.6609, and if you see this probability, this is the probability value, and this is much larger than the 5%. So what will you do? You will accept the null hypothesis, and the null hypothesis in this case is there is no heteroscedasticity. So if there is no heteroscedasticity, it means that everything is fine. Okay, model is not affected by heteroscedasticity issue. Fine. So this is the way. And again, if you are interested to have the results of, let us say, for Harvey test. Okay, so this is, there is no issue of heteroscedasticity. Okay, again, if you are interested to see for any other test heteroscedasticity, let us say Gleiser test. Okay, there is no heteroscedasticity. So when, if this value is less than 5%, then there will be the issue of heteroscedasticity. So now finally, I just want to write down the equations for different tests. So this was the equation when I was taking into my account the Bruce-Pagan test. Okay, but if there is Gleiser test, so if I come down, and I think I gave some space where I wrote, this was the Bruce pagan. No, I think I didn't write. Or otherwise I can simply write it down with my hand. So Gleiser test. This is the second test to detect the issue of heteroscedasticity. Gleiser test. Gleiser LM test. So you can have the result for this if you're going to use Eviews straightforwardly, or otherwise if you are going to manually do it, if you want to do it manually. So mu I hat, mu I hat, mu I hat means basically this is the value of E. Mu I hat, you know, mu I hat is equal to E, or you can also write it down as EI that we found in Excel. Okay, this will equal the same terms that were there in the Bruce-Pagan test. Delta naught plus delta 1 x1 plus delta 2 x2, and I is there with this because this is the cross-sectional data, plus so on, plus delta k x ki plus vi. This is the error term. So this is same as was there in the Bruce-Pagan LM test. Okay. Then there is another test that is called the Harvey-Godfrey LM test. Harvey-Godfrey LM test. So Harvey-Godfrey LM test, if you are going to consider, then you will consider the log of mu I square, log of mu I square, and the remaining right hand side will remain as it was in the previous two tests. Delta naught plus delta 1 x1i.
तो ये स्टार्ट में नेचुरल लॉग लिखा हुआ है आपने,
Yes, ln plus
और
so
म्यू
on.
आई स्क्वायर.
No, mu I square, yes, or simply ei square if you take into your this is basically hat. Okay, so you can write it down as ei square, ln log of ei square, and you will regress it on the other values. Those are same in this third test. So ki plus vi. Fine. Then there comes Park LM test. So all these are the tests. You can use any test to find out the presence or absence of the heteroscedasticity. So basically this is the theory, what formula is being used by Eviews to give you the results. Basically Eviews takes into its account these formulae. So ln ei square, same as in the previous case, Harvey-Godfrey test. So ln mu I square, or mu I hat square, or ei square, it is equal to sigma naught. So now the right hand side is slightly different from the previous case. Ln x1i. So you just have ln with xi. In previous equations there was no ln log on, so you have to apply log on the explanatory variables as well. So ln x2i plus so on, and finally you will have k ln and xki, and then the residual term. Fine. Then there comes white test. And in case of Y test, basically we take into our account an interaction term also. In this case, this is the Y test. Y test. White's test. Let me write it down correctly. Apostrophe ns. White's test. So mu I hat square, or in our case, if I write it as ei square. So simply, if you are interested in using this test, what will you do? Ei square is equal to constant term delta naught plus delta 1 x1I plus delta 2 x2I plus delta 3 x3I. And now you have to take square of this term. Initially there was no square on x1 and x2, but now when you will write it down here, you will write down square on this. So x3I square plus lambda 4 and x4I, and you will again take square of this plus lambda 5, and now you will multiply these two terms. I mean x1I multiply by x2I. Okay. So this is the interaction term that you will include in case of White's test. So then finally the residual term vi. Okay.
सर हमने x1i और x2i का स्क्वायर क्यों लिया?
Sorry. Yes, boy.
x1i और x2i का स्क्वायर क्यों नहीं लिया सर?
We have taken. Sorry, x1. This is x1i. This is not x3 or 4. This is x1i. You are correct. This is x1i. This is x2i. This is x1. This is x1i. And this is x2i. Okay. So we are basically taking this care for this. So if you are here in Excel, and these are the series, and you are going to take into your account x1 and x2, these two series. Okay. So if you are interested in x1i square was there. Okay. So x1i square. Okay. So simply take this value, scale this answer. This is the value. Right? Then x2i square. So x2i square, x2. x1 square, and this is x2 square. So in this case, you will use this series. So equal to this value, cap, square, enter, double click. Okay. And then you have to have the interaction term. So for interaction term, x1 multiply by x2. So now equal to this value multiply by this value. This will be your answer. Okay. So now if you are interested in knowing the results, so for that, first of all, you would have to find out the value of E. So when you will solve this whole model or system of equation, when you will solve, you will have the value for E. Okay. How will you have? In this case, how can you have that value? The value of E, residual value. If you have alpha 1, or you can say beta, in this case, if you see there was delta naught, delta 1, delta 2, delta 3, delta 4, all these values. Okay, and then you multiply this with these terms. Okay, you will have, what will you have? Mu I hat, and then you will take care of that, as you do in the case of the dependent variable. So in this case, this is your dependent variable. Basically, you are taking it as dependent variable. So when you will have all these values, delta naught, delta 1, so you can have all these values if you use the if you ask Excel to give you the regression results. How? Data analysis, regression. Y, this is your Y. Input range, all these variables. Labels are there. Output range, this is your output range. Okay, residuals, I also need residuals. Okay, residual plots are not required, residuals are required. Okay, this is the output and these are the residuals. These are the residual values, if you see. So Excel can straightforwardly give you these values. Fine. So what is basically Excel doing for you? It is giving you the coefficients for all used explanatory variables. Okay, these are the explanatory variables. So now you know that as in the simple regression model, I found the value for E y minus y hat. So once you have the y hat, then you can find out the value of residuals. So in this case, if you see, residuals are there, Excel is giving you. Okay, so you can use these residuals. Understand? So now I have the residuals. So once I have the residuals, now I can regress these residuals on the dependent variable, this dependent variable, to know about the issue of heteroscedasticity. And basically these are the residuals, and if you are going to use the White's test, then you would have to take the square of these residuals. So E square, now you can have E square, E square. So what will be E square? This value, square of this value, square of this value, this is the value. Double click. So this is your E2. Okay. So now if you are interested to know the heteroscedasticity manually, okay, so how will you? You will regress this E square on all these terms, on all these. So then you will have, if there will be some relationship between E square and these terms, it means there will be the issue of heteroscedasticity, otherwise not. So now I'm going to have the regression results where I will regress this on all the explanatory variables. So let us see. Regression. Okay. Output range. First of all, input range. So now my input range is this. Fine. And X, these are all X values. So this is the input X range. Labels are there. Output is there. Residuals now are not required. I am just interested to give it the output range. So I want to have these results, let us say, over here. Okay. Okay, there is some problem, but overwriting basically is there. Therefore, it was saying that whether should I paste or not. Okay, so I want to separate it from that. So this is the output. Okay, so now you have to see what is this probability value. Okay, so probability value, if you see, all values are greater than 5%. Okay, if you can observe. So it means that when you are taking into your account x1, so the null hypothesis was there is no relationship. There was no relationship between x1 and the residual scare. Okay. Similarly, if you see this, there is no relationship between education and the residual scare. Okay. So in if you see all these cases one by one, in all cases you are going to accept the null hypothesis. There is no relationship. So if there is no relationship between the explanatory variables and the residual scare of residual term, there is no relationship. It means that there is no issue of heteroscedasticity, or this indicates the absence of heteroscedasticity in the system, in the model. Fine. Is it clear? Is it clear? Clear or not? Are you with me?
Yes, sir. Clear है.
Are you with me?
Yes, sir.
At least you can say yes or no so that I may know that there is no signal
Yes,
issue,
sir.
there is no internet problem.
Yes, sir.
आवाज आ रही है?
Okay, fine.
Yes, sir.
Yes,
Clear.
yes, now I am listening. Okay, so this was the white test, and there is another test that we call Quenker Bassett test. Quenker Bassett test. So fortunately, there is no issue of heteroscedasticity in our model. If this problem was there in our model, then we can simply take the log of the variables to have the results. And this log, by taking log, we can remove the issue of heteroscedasticity. Equal to, definitely EI is equal to sigma 1 yi hat square. Yi hat square plus the error term. So if you see in this case, what are you going to do? You are going to regress. There is no intercept term. Simply the slope coefficient is there, and you have to regress yi hat square on this. So let us see what happens in this case. Yi hat square is required. I had scare. What is this? Predicted income Y? Why I had? This is why I had. You can at least say yes, so that I may know that you are with me.
Yes, sir.
Okay. So I'm going to use another sheet for this. This is Y hat. This is Y hat. And you have to have the scale of this term. So Y hat scare. care of y hat term. Okay. So simply takes care, have this value, takes care of this, press enter, this is the answer. What were the residual values? And basically the square of residual values. So copy this, paste over here. So now you have to regress this on this Cuenca test. Input range, this is your input range for y, dependent in this case, and this output range labels are there. Yes, output range, I want to have my answer over here, the results over here. So press OK. This is the result. Okay. P value is so small if you see in this case. 2.896 raised to the power minus 37. It means that 0.00036 zeros and then 2. So small as compared to the 5% level of significance. It is so small. So small means you are going to reject H naught. What is H naught? What is H naught? There is no relationship. There is no relationship between y square and ei square. Okay. There is no relationship. Or in other words, you can say this delta 1 is equal to 0. What was H naught? Delta 1 is equal to 0. And delta 1 is not equal to 0. This was the alternate hypothesis. So probability value is so small, or otherwise if you see the t value, this see the t value 171.8869, a huge value. So you are going to reject H naught. What is H naught? This is your H naught. Reject this, accept this. This means that there is relationship between this and this, y hat and this. Okay. So if there is relationship, then there is issue of heteroscedasticity. Cuenca test. So, but basically we are interested in just knowing that whether there is heteroscedasticity in the model or not. So if there is heteroscedasticity, you can remove it by taking log. Otherwise, you can check for detection. So many tests are there. Normally, Bruce-Pagan test we use and have the results regarding the presence or absence of the heteroscedasticity. Okay, so these are different tests. Okay, so I think we have done so much regarding heteroscedasticity, and now you are able to solve the questions manually if any question is there in the examination. So you can use any test, especially Bruce-Pagan test, if you are interested to know whether there is heteroscedasticity in the given model or not. You can simply use the Bruce-Pagan test to find out the answer. Okay, so this is all about heteroscedasticity. Inshallah, we will discuss autocorrelation in the next lecture.
Inshallah, sir.
Wish you very good luck, and wish you very good luck for the midterm that you have attempted in the previous week. Inshallah, I will try to give you the results, and hopefully, the assignment is there in my drive that I gave you in the previous. I think it was 2 weeks ago. Then I gave you an assignment, and I think on Friday, last Friday, it was due.
Yes, sir.
So I think all of you have submitted the assignment.
Yes, sir.
Inshallah, meet you next week.
Yes, sir, we have submitted the assignment.
Inshallah, meet you next week. Thank you very much.
inshallah, sir.